Okay, so before we start on going over the explanation, looking at your calculator, we want to make sure that it's in the right mode. So go to your mode button.
Wait, I just spelled it. Oh.
It's right next to the second function key. And go down, arrow down to the radian and over to degree, and you want to press enter. You want to make sure that your degree is turned on and not the radian. They're both different ways of measuring angles, but we want to measure in degrees today. Okay, and then press second and quit to get off that screen. And then we're going to work with that in a little bit, but it's all set for when we need it. So let's look at the notes that I just passed out to you on page 5. Make sure you're on the right side. Look down and make sure it's on page 5. Trig functions in right triangles. So I'm just going to read through and then we'll do a couple of examples. Trig is the study of relationships among the angles and sides of a right triangle. A trig function has a rule given by a trig ratio, which is a ratio that compares the side lengths of a right triangle. If theta is the measure of an acute angle of a right triangle, OPP is the measure of the leg opposite theta, ADJ is the measure of the leg adjacent to theta, and HYP is the measure of the hypotenuse. And then the following are true. And so just to kind of refresh your memory, I'm going to use the triangle from number 1 down at the bottom there. The side across from your right angle is always the hypotenuse. That does not change. So when you're using the Pythagorean theorem, this is always C in the Pythagorean theorem. The other two sides are called the legs of the right triangle, and it doesn't matter which one's A and which one's B. They're interchangeable, but C does matter. C has to be the hypotenuse. So if we have this angle here, theta, and theta has like a little line going through it. It's not just an open circle. It has a little kind of squiggly line that goes through it. So it would look kind of like this. Okay, that's theta. Here's your angle. And on number 1, they give you the side across from it is 5. So this is the one that is across or opposite. And then they give you this side, the hypotenuse is 13. They don't give you the side that's adjacent to it, and this side is adjacent because it helps make up the angle. They never call the hypotenuse the adjacent side. It's always hypotenuse. Okay, so it says on the instructions, find the values of the 6 trig functions for angle theta. So I have the hypotenuse, I have the opposite side. I'm going to mark that up and put opposite. I need to find the adjacent side. So I'm going to use the Pythagorean theorem. Okay, so I have the a squared plus b squared equals c squared is the Pythagorean theorem. A and b you can interchange, but c is always the hypotenuse. So I've got a squared plus 5 squared equals 13 squared. A squared plus 25 equals 169. A squared is 144. And a has to be 12. We're only going to use the positive root because we're talking about a measurement. So when you measure things, you use positive numbers. We're not going to worry about the negative root. So now I have all 3 sides, and I can write all of the ratios I need to. So I'm going to write sine theta. And then they're also giving you some other ratios. They have below that sine theta in the box, the cosecant. And that's like the inverse for sine. So your sine ratio is the opposite side over the hypotenuse. So that would be 5 over 13. The cosecant is just the inverse of that, 13 over 5. Then we have cosine theta, and the inverse for that is the secant of theta. So cosine is the adjacent leg over the hypotenuse. The secant is going to be the inverse, or 13 over 12. Then your last ratio is the tangent of theta, and the inverse for that is cotangent. So tangent is opposite over adjacent, which is 5 over 12. And the cotangent is just the inverse of that one, so it's 12 over 5. So that's all you have to do for that part when they're wanting you to write the 6 trig functions. Yes?
Why don't we like put it in the calculator and like take the actual number? Why do we make it like that?
That's on the other side of the paper when you do that. They're asking you to do something different. And you want to leave them as fractions or radicals, and you want to simplify. So if you can reduce the fraction, you want to go ahead and reduce it. Okay, so I don't want any decimals on this side, on this type of problem, just fractions. Okay, so looking at the bottom, you have a right triangle, and angle A and angle B are acute. So I can draw that right here. So this is side C, and it doesn't matter which is A and which is B. Those are interchangeable. So if tangent of A is 7 over 12, what is cosine A? So traditionally they have the angle across from your side. So I'm going to make this angle A right here. And if the tangent is 7 over 12, I know that the ratio for that is the opposite side over the adjacent side. So that means that A is 7 and B is 12. The tangent ratio is opposite over adjacent. Okay, but to get the cosine, I need to know what the hypotenuse is. So I've got to use the Pythagorean theorem again. Okay, so A squared is 49, B squared is 144, that equals C squared. So I've got C squared is 193. So that means that C is going to be the square root of 193. And if you can simplify it, do, but that's a prime number. It's not going to simplify any. Okay, so your cosine for angle A is the adjacent side over the hypotenuse. It's going to be 12 over square root of 193. And you can't leave that radical in the denominator. So I've got to rationalize it by multiplying top and bottom by the square root of 193. Okay, so after we simplify, cosine of A is 12 radical 193 over 193. And we're just going to leave it in that form. Don't change it to a decimal. Any questions?